Good afternoon. Today we are going to discuss about a case study, which was occurred in majority of cities, like Delhi, Chennai, Mumbai, etc. So the case study is this mainly related to the British international standard with related to the wiring rules. So we have to follow the international standard of wiring. So if the wiring is not good, the several accident will be takes place. So the case study is mainly based on the fire accident. So what is the case study actually you are taken?
So Delhi faces around 440 fire incidents each year, largely due to poor wiring, substandard cables and inadequate safety measures. The Delhi Fire Service reports that 60% of these fires stem from electrical short circuit, overheating and faculty wiring, especially in crowded areas like Sarajahanabad and Jalpat Nagar. Recent tragedies include deaths in Saradar Bazar and Alipur and Pitampura caused by electrical faults and exposed wires. The 2022 Chandni Chowk electrocutions further highlighted poor maintenance issues, with a 12% rise in electrical fires in 2022. Delhi urgently needs better wiring standards, regular inspections and stronger fire safety practices.
Okay, so this is a case study which is mainly held in Delhi. So this is mainly because of poor wiring. So here the majority of industry they are not following the BEEE wiring rules. So what are the rules we have to follow while doing the industrial wiring or domestic wiring? Okay, so we will discuss one by one. So what is the main issue? What we have to avoid this?
So in order to solve this issue, the AC and DC circuits should be separate.
Okay, so in majority of industry or domestic application, the AC and the DC will be taken in the same duct. Okay, if you are having some of the duct line for wire, the AC wire and DC wire will be taken in the same duct, same pipe. So that should be avoided. So AC should be separate line, DC wire should be and separate line. So if you are isolating the two AC and DC, we can minimize the fire accident. Okay, one thing. And any other?
In a phase system, the phase should be indicates yellow, blue and red, and neutral should be in black and ground should be in gray.
So from the statement, so if it is three-phase system, we are using the industrial application. The phase wire should be indicated in the color of red, yellow, blue. Okay, and the black wire especially is used for neutral alone, and for earth we have to use green. So we should not use the black wire for phase like R phase, Y phase, B phase. We should not use black and green. Okay, so the phases should be red, yellow, blue alone. Okay, now so this also it avoid the fire accident. Okay, done.
For light load, fuse amps should be maxed at 5 amp.
Yeah, good. So if you are using light load alone, that is there is no fan and there is no some other load. If you are using only light load, the fuse should not exceed more than 5 amps. Suppose if any fault occurred in a lighting system, immediately the fuse will trip. Suppose if the fuse rating is beyond 20 amps or 30 amps, so it won't trip. So definitely now it means some of the fault will occur in the lighting system and it may create fire accident also. So if any fault is occurred, immediately the MCB or fuse will trip on. So that the maximum fuse range of 5 amps is prepared for light load, only for lighting load. Okay. Done.
If danger code should be kept if the current voltage is above.
Okay. So if in certain place, if the voltage level is beyond 250 volt, like beyond 250 volts, other than single phase. If you are using three phase means it will be 450. If the voltage rate above 250, we have to keep a danger board, abayam. We have to keep a danger board with the color of red color board, and we have to keep in all the distribution board. All the distribution board and cable where we are using the above 250 volt. So this also can reduce the fire accident in this industrial application.
So mainly total load the circuit should not exceed 50 watts and the point should be less than 10.
Point should be less than 10. Okay, good. So if you are taking a single wire from a single switch, the maximum load of 750 can be connected. Okay, so you should not exceed 750, and from a single wire maximum of 10 point. Maximum of 10 point means 10 switches can be used. for a single circuit. If you want to use more than 10, you can take another line, you can take another circuit. So that only it can be followed means we can able to minimize we can able to reduce the fire accidents. Okay, if you are connecting more number of pine, the load will increase. The load increase, the fault may occur immediately. Okay, there is a way to occur faults. Okay, done.
So for domestic purposes, we should use only 3-pin wires, not 2-pin wires.
Okay. So if you go for domestic as well as industrial wiring, so we are always preparing the 3-pin plug female socket. Okay. So one is for phase, neutral, and one is for earth. Okay. So if any fault current or any leakage current which is direct in this system, immediately without any time delay, the fault current that will be returned to the ground. Okay, if the third terminal is not there, only 2 terminal will be there, 2-pin plug point. So only phase and neutral. So the fault current will not return to ground. So the fault current will be circulated inside the body of the metallic body. So if you are touching the metallic body, either a DVD player or FM or behind the fridge of the metallic conductor. So wherever you are using the metallic body, when we are touching the metallic body, we will get shocked. So in order to avoid that shocking, so we have to use the third pin, the 3-pin socket alone. It can be recommended. Okay.
Switch in base wire model here.
Okay. Another important. Suppose just you can think. So all the switches should be connected in phase alone, not in the neutral wire. For example, so this is a fan. There are some of the problems will occur in the fan. So I am going to repair. I am just to switch it off. Here. The phase is directly connected with the load and neutral is connected with fuse switch. Okay. So I am touching the fan. I am working on with the fan. So the phase is directly coming, and with the help of ground, the earth will be passed through my body. So their phase and through my body, earth will be passed. So phase and earth, negative terminal is connected. So the current will flow through my body. So I am getting shocking. Okay. So this will be a major issue in the domestic as well as industrial wiring. So all the live wire, that is phase, should be through switches alone. Suppose if the neutral is directly connected with the load, okay, and phase through the switch. So if I switch off the switch, the phase won't come here, only neutral will be there. And from my body, neutral is there. So there is nothing happening. Okay, so all the switches should be connected in phase wire alone. That is live wire only, not with the neutral. Okay, so here.
All the switchboards should be above 1.5 meters.
Okay. So all the switchboards, you can see here in the residential application, all the switchboards should be connected above 1.5 meter. Because already you've seen in Chennai, many, especially in the winter, that is the month of December, so there will be a heavy fluid will be there, so the water will enter into the home. Suppose if the switchboard is near to the ground, so the water will enter into the switchboard. Am I right? So there will be a short circuit will occur. There will be a short circuit occur, and the water is acting as a conductor medium, the water will flow through the conductor. So in order to avoid, and also in many of the residential application, the childs always play with holes, small amount of holes. Okay, so if it is above 1.5 meter, so the child won't touch on the switchboard. So in order to for safety precaution, the switchboard should be above 1.5 meter. Okay. Any other points?
So all the fans should be above 9 feet from the ground.
Above 9 feet. Above 9 feet means around 2.5 meter. So all the fan should be above 9 meter. So why we have to keep above 9 means, if it is above 9 means we won't get the air circulation. We won't get the air circulation. If it is below 9 means suddenly some of the people are with the height of 6.5 or 6. Am I right? Okay. Suddenly they are raising the hand. Okay, now the blade will touch the hand. So that will be a damage to the human body. So in order to avoid this, as per the BEEE standard, all the fans should be connected above 9 feet. That will be recommended as per the wiring rules. Done.
All the switches and boards should be fixed on the left side of the
Yeah, good. So all the switchboards should be kept at the entrance of left side, the left of the entrance. Why? So normally when we are entering into the home, the majority of door, we are opening in the right side. We are opening in the right side. So the switchboard should be kept in the left side of the door, so that only we can be able to access easily. If suppose if it is the right side, so the switchboard is present behind the door. So we have to enter and we have to turn back and we have to switch on the lights. Am I right? Suppose Now it is always a concrete one, but in we go for conventional in olden days, majority go to be. Am I right? Okay. So there will be a snake or some of the during the rain season, some of the okay la. So snakes will be mainly snake. It is a poisonous one. It will be entering. Suppose if you are entering into the home, suddenly it will attack. So in order to avoid that particular issue, before entering you have to switch on the lights, so that it is recommended to keep the switchboard in the left side of the entrance. So the door should be in the right side. So this is for to prevent the fire accident, also for the safety of human being. So the wiring rules should be followed internationally. Okay. So if you are following these rules, the accidents can be minimized as well as we can able to ensure the safety. Our safety we can able to minimize. Okay. Thank you.